Unit 2, Lesson 1, Understanding Place Value. New unit. Our objective for today is to explore the multiplicative relationships between places in multi-digit numbers, also to understand the place value system. So we're dealing with multiplication and the relationships with multi-digit numbers and their place values. We are doing this because one of our Indiana standards is to recognize the relationship that in a multi-digit number, a digit in one place represents 10 times as much as it represents in the place to its right, and also a digit in one place to the left is 1/10 of what it represents. So let's start off by doing a little warm up. Remember, in Unit 1, volume equals length times width times height, or volume equals the area of the base times height. So take a minute, solve these on a piece of paper or a slate, and come back and check and see if you still got it. All right. For number 1, 7 feet by 5 feet by 4 feet, that should be 7 times 5 times 4. I know 5 times 4 equals 20, and 20 times 7 is 140. I do have a label missing. It should be 140 cubic feet. So we would add that onto the end. Cubic feet. And then for number 2, base area is 100 square feet, and the height is 12 feet. So we know that would be 100 times 12, which gives us 1,200 or 1,200. And again, we need to say square feet. All right, so moving on. Let's get that out of the way. There we go. So some vocabulary words. We'll have 3 vocabulary words, terms, phrases that we want to go over as we start this new unit. You'll see here on this slide, we've got place value and we have standard notation. Place value, a system in which the unit of a digit depends on its place or position in a number. In our base 10 system for writing numbers, moving a digit one place to the left makes that digit worth 10 times as much. Moving a digit one place to the right makes that digit worth 1/10 as much. So when we move to the left, the numbers get bigger. When we move to the right, the numbers get smaller. For example, in the number 450, the 4 in the hundreds place is worth 400. But in the number 45, the 4 in the tens place is worth 40. Standard notation, the most familiar way of representing whole numbers, integers, and decimals. In standard notation, numbers are written using the base 10 place value system. For example, standard notation for 356 is 356, 356 in digits. There we go. All right, last word, expanded form. This is a way of writing a number as the sum of the values of each digit. Here's an example. In the expanded form of 356, it can be written as 300 plus 50 plus 6, or we could do 3 times 100 plus 5 times 10 plus 6 times 1. We'll take a closer look at that in this lesson. But you'll see we have 3 in the hundreds place, 5 in the tens, 6 in the ones place. So go ahead, turn to page 37 in your math journal, do problems 1 and 2, pause this video, come back and check out the work together. Number 1, you should have had the following. The value of 2 and 2 is 2. The value in 2 and 23 would be 20. Value of 2 and 200 30, we see it's 200, 2,300, you got it, 2,000, and finally 23,000, it'd be worth 20,000. Hopefully you got all those right. Let's look at the position of the value of the 6 in each number on number 2. Now, remember, our number system assigns every digit a value based on its place in a number. This system is called place value. And also, in today's lesson, we are going to learn about our place value system a little bit more and how to represent the values of the digits in the numbers. So, 65,000, 60,000. 6,500, 6,000. 650, 600. 65 would be 60, and 6 would just equal 6. Pretty straightforward, right? Well, when we start using multi-digit numbers, we would use a chart like this to help us figure out place values. So we see, starting on the far right side, we start with the ones place. Let me focus on this. We start on the right, we have 1. So that's where, like, the number 6 would go. Then we have the tens place, the hundreds, the thousands, 10,000s, and 100,000s. Notice up here, we see that when we go from the ones to the tens, we multiply by 10. Then we multiply by 10 each time, okay? And you can see you can represent each place value. An O, the letter O represents the ones place, a T, the tens, H, hundreds, K represents thousands, 10K, 10,000s, and 100K, okay? So here, I might write the number 6. But if I move up to the new place value, I would write 60. And then this is where the 6 equaled 600. And then if we added in the 6,000s, you can see the place values where they land. Okay, so we have 6,000. Using a chart like this can definitely help you when you are trying to figure out the names. So you would multiply when you get bigger, and you see you multiply by a fraction if you move to the right. What I want to point out here, okay, so this way is we're moving from left to right. That means we're getting smaller, okay? The number, the place value is getting smaller here. That's the relationship. You see that they multiply by a fraction. What I want you to understand is multiplying by 1/10 is the same. So multiplying by 1/10 is the same as dividing by 10. So when we move to the left, we multiply by 10. When we move to the right, we divide by 10. So here, maybe we start off with the number 600,000. Okay, because I see that my 6 is in the 100,000th place. And I know right here would be a comma. But I then divide it by 10, and that would then give me 60,000. Okay, I could divide it by another 10 and get 6,000, and another 10 would give me 600. Okay, so we can say we can take 600,000 here and divide it by 10, 100, 1,000. We can take 600,000, divide it by 1,000, and get 600. That's how this chart works. It's moving from left to right, and remember, it's getting smaller. Okay? Clear that up. So a pattern is a mathematical structure. Observing and describing mathematical structures like place value relationships, they help us understand our number system and solve the problems in a more efficient way. Taking a look at this number, 65,582. If you've got your math notebook, this is a great time to write down some notes so that you can refer back to them as you're doing your independent work and as we go on throughout the year. This number is written in standard notation. Standard notation is the most common way that we represent our numbers. We represent them with digits, commas, decimals, okay? So this is just a standard notation number. Another way to represent a number, though, is by writing it in expanded form. Expanded form represents numbers as the sums of values of each digit. So before we move on, I remember at the beginning I said 60,000. So the 6 is worth 60,000. What would the other digits be worth? Here we have 4 different representations of expanded form. We have 6 10,000s plus 5,000s plus 500s plus 8 10s plus 2 1s. We know because each number is in a different place value. Okay, so we see that the 6 is in the 10,000s, the 5 is in the thousands, the next 5 is in the hundreds, and so on. 8 10s, 2 1s. So each one of these represents that. 6 outside the brackets, 5 outside the bracket of 1,000. Or this is the one that we originally probably thought of, 60,000 plus 5,000 plus 500 plus 80 plus 2. And then this last one, because we know that 6 times 10,000 equals 60,000. So each one of these would represent its place value. Take a moment and think, which one do you like the best? What kind of expanded form do you prefer? They're all correct. When thinking about the expanded form, the parentheses in that fourth example that I just showed you, they're not necessary. You don't need them because order of operation tells us to do each multiplication problem first and then add. But it makes it easier to see the place value patterns. I always like to do the parentheses ones. All of those different versions, all of those that we are looking at here, they all represent the same number. 4 different ways, well, 5 if you count this, but 4 different expanded forms for the exact same number. So what we're going to do now is we're going to turn to page 37 and 38 in our journal, and we are going to complete some problems based around place value. So what you can see here is 3, 4, and 5 on the screen. 3, 4, and 5, we see to write the numbers in expanded form for 3, and then write the numbers in standard form for number 4. And then how does expanded form help you see the patterns in our place value system? Take a moment, pause the video, and then come back. We'll do a couple of these together, and then you'll see the answers. And here we have 6 and 7. Number 6 says write the value of the 4. So we're only looking at the digit 4 in each number and talking about how much it is worth. We're not asking what place value, but we're asking how much is it worth. Then on number 7, write the value of the identified digit. Then fill in the blank with either 10 times or 1/10 of. Remember, this is a good spot to write this note down. Remember that 1/10 of, and I like to put equals divided by 10. Okay, those mean the exact same thing. And it's okay if you do divided by 10. They're the exact same. And that's what helps me remember. Okay, so A is the 7, the 4, the 2, and then the 1. So pause the video, come back, and we'll check our work together. Okay. 8 and 9. 8 says write a number where 5 is worth 500. Write a number where 5 is worth 10 times as much as that one in A. And then see, how did the position of the 5 change in your number? I'm looking for, did it move to the left any? Did it move to the right? And how many spots? And then 9, you're going to do that for the 3 that's worth 30,000, and a 2 is worth 20. So you're going to have some other digits in that number. Write a number where 3 is worth 1/10 as much. Remember, that means divided by 10. And the 2 is worth 10 times as much. And how did that position change? Okay, so pause video. Come back. By this time, you should have done your work, and you should have seen a couple examples that I did from these problems. Here are the answers for 3. Take a look at those. You can read them to yourself. We've already talked about how to do some of these. Number 4, you see 450,362, 93,491, 32,579. Now, number 5 says, how does expanded form help you see the patterns? Well, expanded form shows us how much each digit is worth. You can see that up here on 3. It shows how the value of each digit depends on its place in the number. 6, we see that the 4 is worth 40,000. B, 4,000. C, 4,000,000. D, 400. E, 400,000. And F, 40. 7, we can see here that it was 700, 7,000. This one is 1/10 of the 7 and 7,328. Remember, 1/10 does mean divided by, but the phrase 1/10 of makes sense in this sentence. And again, you should have seen some of my work for a couple of these problems already. 40 for 1 in 32,000 is 10 times value of in 32,904. C, we've got 200 here, 20 here. The value of the 2 in 30,275 is 10 times the value of the 2 in 18,921. And then finally, the 1 is worth 100 in this number, and it's worth 1,000 in this one. The value of the 1 in 90,106 is 1/10 of the value of the 1 in 21,000. And 8 and 9, here are some samples. 2,542. So you can hear when I say the number, the 5 is worth 500. A sample of making that 5 10 times more, it means it's going to move one spot to the left, 5,242. Again, these are just samples. You could have had something completely different. As long as your 5 was in the hundreds place and your 5 was in the thousands place on part B. Because again, the 5 moved one place to the left because it was getting larger by 10. A sample for 9A would be 34,129 because the 3 needs to be worth 30,000 and the 2 needs to be worth 20. So I'm moving my 3 to 1/10 as much and the 2 is 10 times as much. So I know my 3 is going to move down one spot and my 2 is going to move up one spot. So we could do 3,200. We don't have to have all those other digits. They only told us the specific ones. And again, just an example, just a sample, but your 3 does need to be in the thousands and your 2 needs to be in the hundreds because the 3 is moving one place to the right. All right, lesson 1, understanding place value. Again, we explored the multiplicative relationships between places in multi-digit numbers, and we also are continuing to understand the place value system. Before we end today's video, I'm just going to show you a quick preview of today's independent work. What you are going to do is you're going to complete the attached Google Slides activity. There are 3 tasks for today's independent work. Task 1, you are going to watch the Place Value Khan Academy video. The link is in the presentations right there. Task 2, you're going to complete the Math Box 2.1. And task 3, you're going to complete the Place Value practice. So when you have an assignment like this, again, you just click here. It'll open it up for you. So you can see at the top, task 1, right here is where the place value. Task 2, it says complete the math box. Then you need to insert a picture of your finished boxes. So you're going to put your picture here, and I have included a screenshot of how to insert those pictures, but I'm going to show you. So you're going to go to Insert, Image, and then you're going to go to Camera, okay? And that's where you're going to take a picture, and you'll have to either block or allow, and then your picture will come up there, okay? Then we have the place value practice, okay? Following along, you have some places where you need to type. You need to compare, okay? So you're going to tell me which one's larger, what's the difference. And you're going to say, you're going to come up with a question. What could you ask your friend to make sure that they're understanding how to find the value of a digit? So say that you're helping someone out. What would you ask them to make sure that they know what they're doing? Again, comparing the 2 numbers. Then finally, if you finish when you have time left over, you're going to log on to IXL and you're going to work on, it's okay if you don't complete them today. We'll have time to work on these later. So maybe I'll change that. Work on A1 and A2 on IXL. Okay? Later this week, we're going to be taking Evaluate on Tuesday. We're going to be doing 2.2 on Wednesday and 2.3 on Thursday, and then finishing up Evaluate and doing some data recording from our Evaluate. Okay?